Hey everybody. If you don't know me, my name is Alex Parker. I'm a product manager here at Replicated and have the privilege of talking to Tom from H2O today. We're going to be talking about delivering an AI appliance with embedded cluster. Tom, you want to introduce yourself real quick?
Sure. Hi, everybody. Thanks for attending, and thanks to the Replicated folks for inviting me. I've been with H2O for almost 12 years now, and have a technical background, worked with lots of our products, worked with lots of our customers, and have been very hands-on actually with the things we're going to talk about. So everything we'll chat about is a firsthand experience. So thanks for having me.
Awesome. Well, to get started, why don't you give us a little bit of background about H2O AI?
Yeah, sounds great. Thanks. So the company was founded in 2012, got over 200 folks, very heavy on the technical side, with a real emphasis on predictive and generative AI software products. So we're a software company. We deliver software products, and for most of that time, we've delivered predictive AI software products, a platform which really requires the customer usually to be involved in building models with their own data around their own use cases. And so the kinds of folks we would work with would often be, banking, insurance, telco, healthcare, retail, things like that. The kinds of companies that would hire data scientists and want to train models. But about 3 years ago, when the generative AI wave really took off, we absolutely wanted to align with that. And what's interesting about it is you don't need with generative AI to train models for every use case now. Um, so instead of really doing data exploration and customization in the way that we would have traditionally, now we can think more about application customization. You can think about subject matter experts, analysts, or human agents as your users. And what that's done is basically kick up a renewed interest, let's say, in turnkey solutions. And so one of the things we'll talk about are a particular use case and how to deliver it throughout the talk here.
Yeah, that makes a lot of sense. Just how you would be seeing the change in persona from the possibly more technical person who's involved in the model training to more of that subject matter expert persona for the specific task they want to use the generative AI model for. Um, why don't you talk a little bit about the specific use case that you had in mind here for this AI appliance?
Yeah, thanks, Alex. So this particular use case, and there's really no limit to what you can do. This is just one specific one that we happen to have a particular law enforcement agency that's really interested in, that was brought to us by one of our hardware partners, is about wanting to take lawfully intercepted phone calls of people that are, let's say their number has been flagged for being of interest, and capturing audio files at the carrier level and then delivering those into one of these turnkey AI appliances so that it can live inside of a call database where the AI software, our AI platform software, which has large language models and RAG, retrieval augmented generation, and then a custom application sitting on top of that intended for the particular user set that we're targeting here, which is a law enforcement agent, and then basically enabling them to do transcription of the calls, translation of them, summarization, chatting with them. What's interesting about this is the calls themselves, they don't need to be in English. They can really be in any language, but the question and answer that an agent might do to chat with them can be in a different language. So these LLMs, once you've ingested the words, basically what they do a really good job of converting that into basically a mathematical representation, which is almost language invariant, which is really, really, really neat.
Yeah, neat. So these calls are kind of ingested and transcribed. So now you have a text transcription of all these calls, and then your law enforcement agent could just converse with those through text, right? They can just ask questions. Is there a call that where this sort of language was used. They could just sort of interact via normal language with this to query the different calls that have been ingested and transcribed. Is that right?
Yeah, you can imagine that the law enforcement agents might have a set of questions that they like to ask the database of calls and have the LLM be able to give an answer. So like an example might be, has anybody been describing something that sounds like illegal activity? Or are there any meetings that are planned for, next week, for example? Basically, the instead of needing to listen to every call now, basically this database is able to interact with the large language model and take the questions of the people and to be able to automatically deliver an answer.
Yeah. I haven't actually asked you this, so I'm curious to know the answer. But you mentioned before how the persona is a bit different. Like with the predictive models, you need to work with people that can help get into the data and train the model. Whereas in this case, you have a pre-trained model that is already trained on, all the language that's out there basically, and then some
Yeah.
normal person who might not be technical, like this law enforcement agent, is just able to directly interact with that model and ask questions of it. Does that sort of incentivize you further to have a simpler deployment model for those people because you don't have to have the more technical data scientist type people even in the picture. You can just go straight to the law enforcement agent and have them conversing with it. So is that sort of raising the bar for how simple you want the deployment experience to be?
Yeah, absolutely. One of the things to kind of think about here is, we're not delivering this to a tech company. We're not delivering it to technical people, really. I mean, they'll have probably somebody that's going to have to take the appliance and put it in a rack. But really, the end user and the people that are interacting with it are people trying to do their job, right? It's not going to be tech people. So
Yeah.
absolutely, everything needs to be simplified in order to get the best experience, including for us from a support standpoint.
Yeah, makes sense. So let's tell us a little bit about the actual appliance that you're delivering.
Yeah. So this is what the physical appliance looks like, and you can see it's a 2U rackable thing. It has sort of the typical pizza box kind of form factor, except it's a little taller. It's quite generously provisioned in terms of resources. No surprise, AI takes a lot of horsepower, and so you can see what's inside of it is a pretty generously spec'd out thing, including five GPUs, which we use to actually run the AI software and the LLM. Most specifically, though, we'll kind of come back to this a little bit later, I think. It's got multiple NICs, multiple Ethernet NICs, which turns out to be really, really handy for delivering an appliance, and we'll get to why.
Yeah, that's great. And then we've also got a little overview of the actual AI appliance stack.
Yeah. So, that bottom section here is the physical appliance, and then we've used Ubuntu on top of that. And I almost think of the Ubuntu host operating system layer as part of the hardware, even though it's obviously not. But it's kind of separate from what we're trying to deliver as a solution. And that solution is all wrapped up with embedded clusters. So you can see the bottom layer there, the Kubernetes, is the embedded cluster K0s that just comes as part of that package. The management software and the configuration, doing that through the COTS, the replicated COTS software inside embedded clusters, really convenient. And what we've done for this form factor versus the traditional data center form factor is really simplify that down. So there's almost no inputs for the customer to give, but there are a couple of inputs that you need to give, and it's nice to have that replicated management layer UI to do that. And then our software sits on top of that. It's the generative AI platform software with RAG and LLM capabilities. We call it Enterprise H20 GPT-E. And then sitting on top of that, using an API to talk to the platform itself is the call transcription and analysis software that we've developed specifically for this use case.
Nice. And then given that this is, basically a server in a rack, and then you've got this non-technical agent that wants to interact with it, what's the user experience for them actually querying the large language model and asking it questions and things like that?
Yeah, it's just a web browser. So the user would have their laptop or desktop or whatever. They'd point to the IP address of this appliance, and just, browser comes up and you log in and work with the software.
Yeah, cool. Okay. So that's a little bit of background on Tom and H2O, the problem they were trying to solve, and then, the solution that they've come up with here, this AI appliance, and seeing all that. So I'm going to stop sharing my screen for now. Those are the slides we have just for that background. We can pull them back up if Tom, you want to refer to them at any other point throughout the discussion. But I think for the
Yeah.
rest of this, we're probably just going to be chatting a little bit. So,
Yes.
thinking about this problem that you had, you've been a customer of Replicated for a while. You've used a lot of our products. You're very familiar with COTS and curl and things like that. But what led you to want to continue using Replicated when solving this specific problem you were faced with?
Yeah, so this specific problem, because it's an appliance, delivery form factor, we wanted it to be simplified. The really, really turnkey approach was super, super important. We absolutely needed, everything to be as easily supported, supportable as possible. And, embedded cluster specifically was really good for that. So the embedded cluster way of thinking is, always just naturally felt like a software appliance to me. And then, we started using it quite early in the life cycle of embedded cluster itself. So when we first got a chance to look at it with you, it was, super early alpha mode. But then when this hardware appliance kind of idea came along, it just felt like a perfect thing, a perfect mesh for the embedded cluster itself. And just from a development standpoint, from an experience standpoint, everything about embedded cluster, it's very streamlined. So it's small, it's lightweight, the packaging is smaller, it's using K0s instead of a full-blown Kubernetes. Everything just kind of naturally felt good. And so it was an easy extension to want to do that.
Yeah, for sure. That makes sense. So I think you'd mentioned to me before too, like air gap support, the Kubernetes support, different things like that. You want to talk a little bit about those pieces too and how those benefited you in this case?
Yeah, for sure. So in terms of air gap support, as a company, our customer base, we've kind of talked about banks and telcos. They've always been air gapped. So our company's always wanted to and done a thorough job of making sure we can deploy our software into challenging environments with no internet. And so that's actually where we first started working with Replicated, is to come up with a best practice workflow driven by you guys, where we kind of fit into the framework to get that out of the capability. And then, this appliance thing is just taking that to the next level. So now, instead of going into a customer data center where the environment is unknown, to simplify the customer experience, providing the actual hardware envelope means you never need to wonder if the environment's going to be correct. Like, it's kind of by definition correct. And that really, for this particular use case, was another kind of simplifying factor. And putting embedded cluster on top of that, like I said, is just a natural, really, really natural feeling of how to do that. So the Kubernetes itself, because our software needs Kubernetes to run, the embedded cluster bringing the Kubernetes along in a way that really just fades into the background helps a lot. So the embedded cluster, for those of you that haven't tried it, basically you grab a single download from the Replicated portal, and it has everything right there, right? The Kubernetes is there, our software is there, the management stack is there. It's all just really super easy, turnkey to work with, and all of those things were factors.
Yeah, absolutely. So yeah, so like as you're alluding to there with embedded cluster, one of the key value propositions is getting Kubernetes embedded along with the applications. Like in your case, you've got someone you just want to provide this rack to them. It's already got everything there. So it sounds like the fact that you have a Kubernetes application that you want to deliver, but you don't want, this, you're giving this customer an appliance that's kind of all in one. So the fact that your stuff can kind of come with Kubernetes and then get upgraded in tandem. So anytime an upgrade comes out, they don't have to think about those different pieces. Those things are just going to get upgraded together. It just makes managing the appliance easier, right?
Yeah, absolutely. In fact, not only does the customer not have to think about it, I also don't have to think about it, which is even better. Um, the fact that the Kubernetes itself gets upgraded as part of the package along with the software is kind of seamlessly is really a nice improvement from the prior generation of the replicated delivery approach.
Yeah. I was actually talking to another one of our customers recently who was deploying into government environments and very secure environments and had run into some challenges there with just the hardening and the security positions that those organizations were taking. And they were considering also deploying an appliance as sort of a workaround there, a way to get there. Have you found that these government and more secure organizations are welcoming to that? They've got their own machines that are very hardened and whatnot. But have you found that they're open to kind of taking this hardware stack in and adding it in, and this like appliance format, for example?
Yeah, you can think of the place that this would run as being on-prem in an agency office, one of many agency offices, and just kind of sliding into, a rack. And they, I'm sure at some point we'll ask more questions about what's inside, but because of the way that they deploy in a secure data center, with a, they just plug in a wire, they haven't been too concerned about that kind of question. Plus, with our background, we give them vulnerability scans and stuff. We can show those sorts of things to help to address those kinds of questions. But the people that are wanting to take an actual appliance tend to be less focused on that kind of question, I'll say.
Yeah. Yeah, that makes sense. Then, as far as like the appliance model, I think we've alluded to this or touched on this a little bit, but it sounds like part of the appeal of the appliance model was the security of the organization, but perhaps also the less technical nature of the end user. Were those the main sort of drivers of wanting to go the appliance route?
Yeah, that and wanting to make sure that the right hardware is there, right? So instead of needing to wait 6 months for the customer to procure hardware to just do a POC, we can deliver them something quickly. They can just plug it in and be able to work with it. So, not only does it speed up and simplify the environment and reduce the need for technical people on the customer side, it just speeds everything up for cases where the customer is, liking that as an approach.
Yeah, makes sense. Uh, with embedded cluster specifically, we've talked a little bit about the bundling up of Kubernetes along with the application, so it's easier to upgrade both in tandem. That benefits both you and the customer through that process. What were some of the other, I guess, parts of embedded cluster that were appealing or made this work really well? And maybe after that, we can dig into some of the challenges you all had faced before and some of the newer things in embedded cluster that had helped unlock some of that potential.
Yeah, like for sure. So as I kind of mentioned before, it's smaller and more compact. So embedded cluster, it feels tighter. The time it takes to stand it up on a new deployment is just a couple of minutes, as opposed to potentially tens of minutes for the old curl style, for example. Because it's K0s and all the plugins and components are integrated, like everything's just really fast. A couple of other things that we really were happy about was, our software is AI software. It needs a lot of GPU capability. The K0s that comes with embedded cluster actually has a really nice plugin architecture, and getting the NVIDIA, GPU operator to work in that kind of just worked. Like it was pleasantly easy to work with you guys to figure out how to do that. So that was really nice. Um, the application binary itself for embedded cluster is nice because it has all the tools inside of it. You have the Kubernetes itself, but then you have kubectl just kind of there. The software images are just there. Everything becomes, simplified and easier, and smaller as well. So the download size itself is, if you're doing the non-air gapped one, it's about 500 or 600 megabytes. It's really not big. And for our, let's say core bundle, for the embedded cluster download, we've kept it to about 5 gigabytes, and then have the really, really big images kind of on the side. And that 5 gigabyte size is a good, nice size for being able to distribute and download. So the other thing that I'll mention is, reset is reliable. So that is a, developer, for the developer experience, that was really, really, really helpful. Having a super reliable reset, I can't even say enough about that. That was very, very nice. So thanks for that.
Yeah, I love using that as well. It's nice to just pull up a single machine, do an install, play with it, reset it back to a clean slate, try again, and iterate like that. It does make that development process a lot easier for me as well. You had mentioned the kind of the out-of-the-box K0's plugin support for the NVIDIA GPU operator, and I'm also thinking about how you had, I think you had to configure worker profiles for some of the work here in embedded cluster as well. And I think all of that's kind of touching on a couple of like advanced capabilities, I guess. Like one of the interesting things about this project for you is like you took embedded cluster and benefited from a lot of the features and functionality that it inherently provides, some of the stuff we've already touched on, the smaller download and the fast install time and the coupling of the application and the Kubernetes upgrades. But you also had to take it farther and sort of extend it to some other capabilities that were possible with embedded cluster, but not necessarily direct features that embedded cluster provided, if that makes sense. So like, the worker profiles, how you were able to use the K0's config to set those up, even though that wasn't a feature that was directly exposed by embedded cluster necessarily. Do you want to talk a little bit about that and how sort of the way embedded cluster was architected to give you access to some of that underlying stuff lets you do sort of the specific use case we had designed it for, but also take it to some of those additional steps that you needed?
Yeah, so I alluded before to our images being big and in some cases side loading some of them. And by big, I mean tens of gigabytes. So statically linked CUDA GPU images with Python as sort of the primary development language, which is what our stack is to a large extent, they're very large. So being able to tweak the embedded cluster config for that worker profile to tell the containerd to be able to do multiple image pulls in parallel turned out to be a really neat kind of speed up trick. So by default, containerd will want to just load each image one by one, and they're local on the appliance, but they start off in the image registry inside the cluster itself. And what we do is basically turn on those settings to allow it to pull multiple of those. And when you've got a really good disk, it's able to do multiple pulls, multiple unzips, et cetera, in parallel, and really, really speed up that first deployment cycle.
Yeah, yeah. For those who aren't a part of Replicated here, which is probably most of you, Tom is very well known at Replicated because the stuff he's doing with embedded cluster and just H2 in general often pushes the boundaries of kind of what we're working on. So Tom's a great source of inspiration and new ideas for things like these worker profiles is a good example where you were able to kind of go under the hood, find a way to make those image pulls happen in parallel, and like that's a feature we could expose in embedded cluster. Like you found a way to do it, but it's something, it's feedback to us then to potentially better productize that, make worker profiles a standard part of embedded cluster. And
this is very, yeah, it's been very collaborative, I'll say. So like the GPU operator stuff too, like the way that we kind of figured out how to do it is just, a brainstorm with your technical folks like Chris, and just come up with an experiment to try it, see if it works. And fortunately it did. It was pretty easy. And now that's, in your documentation as something that's findable on the website.
Yeah. Yeah, I think that's a good plug for us at Replicated too, is that we're always happy to jump on a call, work with people. Like if anyone listening has questions, they're trying to figure out how to do something, they need help. We're always more than happy to get on a call and brainstorm. And I know Tom has taken advantage of that numerous times with Chris and others in particular to help solve those problems. So I think that's a a good example of that relationship and how we've been able to work together, not just with the product, but also with some of the other stuff to help you bring this to market and offer this appliance.
Yeah, that support factor, that Kubernetes support factor has always been first rate. And that was actually one of the reasons that we wanted to work with Replicated originally in the first place, was to have that sort of safety blanket, because we ourselves were at the time becoming adjusted to delivering our software on top of a kube platform. So that's been really helpful. Your folks are always great to work with.
Yeah, absolutely. And I know you've got a lot of people on your team as well that are often interacting with embedded cluster, not just yourself, but others on your team that are using it and getting feedback and working with it too. So
Yeah. There's actually one other technical point that I want to make sure I get a chance to mention, which was alluding back to the multiple network interfaces thing. The Kubernetes itself really wants to have a static IP address. So when you deploy Kubernetes anywhere, much less inside of an appliance like the one we've been talking about, that Kubernetes wants absolutely a static IP address for itself. And so what we figured out kind of, through multiple sessions and working with you guys and eventually a feature showing up inside of embedded cluster to support it, is basically taking one of the NICs at the host operating system level and claiming it for the Kubernetes, and then letting the other one be where the customer can plug in a wire. So you get the best of both worlds. You get that stable Kubernetes IP address that's able to be consistent, regardless of where you take that box and drop it down. And then also the ability for the customer to plug in a DHCP port into the back and basically get easy IP address discovery and kind of get the best of both worlds. And that was one of the toughest challenges we had to figure out how to do properly. And it turned out to become really easy once you guys added the like network interface, or I think flag, to the embedded cluster install process. And then that just sort of became supernatural, like the other patterns of embedded cluster.
yeah. Yeah, let me ask a clarifying question, make sure I'm following that right. So basically you need the stable IP address for Kubernetes, and that's one of the challenges of an appliance where you're going to set it up and configure it in one place and then move it to another place. And so
Exactly.
with this network interface flag with embedded cluster, you're able to create, I guess, what's effectively a fake interface, almost, that like a static IP address that the cluster doesn't really need to use, but it can bind to that, and that's your stable IP address, so that when that moves from your setup over here to the customer, that is static and it's still there. But then Kubernetes is still able to listen on the other network interfaces, so it's still able to work with the network that's actually present in the
Exactly.
customer's environment. Is that right?
Exactly. So the one interface is really meant for internal communication, and then the second interface is meant for, some where the wire plugs in and it can sit on the customer's network and just work seamlessly.
Yeah. Nice. And I think that probably works for the single node case rather than the multi-node case where you would need the other nodes to be communicating through that. But then I assume, like with the appliance model, you're generally, if not exclusively, thinking of a single node installation, I assume.
Yeah. That's a good point. So what we are doing in this, first take at this problem kind of solution approach, is focusing on the one node appliance delivery where everything is self-contained, and there's no inter-cluster, multi-node communication. It's, we could do that. That would work, but then you'd need more sophisticated hooking up of the nodes and joining them and so forth. And that would be exposing more Kubernetes, I think, than we were looking to do for this use case.
Yeah, makes sense. One other sort of lesson I think you learned going through this, which isn't even necessarily specific to embedded cluster, but maybe replicated more generally, is I believe you made a transition from, several different Helm charts and whatnot into a single umbrella Helm chart. And do you want to talk a little bit about that journey and some of the benefits you experienced through that?
Yeah, what we realized is it was really important to be able to have a consistent way of being able to deliver, not just deliver, but test the software regardless of the delivery approach. And so having everything inside of one umbrella Helm chart with one chart, one values file, really, really simplified that, because now all of a sudden, every different kind of way that we would deliver the software, and we've also got like a managed cloud delivery approach and others, now kind of unified on this single workflow, and then having replicated just sit on top of that unified Helm made the delivery really, really more streamlined and easy, instead of having a patchwork of multiple Helm charts. So that's a lot of work, I would say, but the investment is worth it. And if there's one thing that I would tell people that are just starting on their journey of trying to get their software into Replicated, it's figure out how to get all of your pieces into one unified Helm chart, because it simplifies your life a lot.
Yeah, absolutely. It's definitely a recommendation we're increasingly making to people for sure. So thinking about I'm going to try to summarize some of the different points that you've made, some of the benefits you experienced here with the appliance model. So appliance model has proven great for deploying your software into secure organizations that where they need to procure the particular infrastructure, where they have security rules, things like that. So giving them the appliance, you get all the hardware automatically. They're able to just plug that in and rock and roll. With embedded cluster specifically, you've got kind of the faster installation, the very easy setup and flexibility of it, as well as kind of catering to that less technical persona where it's easy to, they don't have to think about Kubernetes, they don't have to think about all the underlying technology. They can just interact with your software basically and have a very simple installation and upgrade process through that appliance.
And not having to worry about what version of Kubernetes was there before, which is really, really important, actually. Simplifying that is a huge bonus.
Yeah, absolutely. So yeah, I think this is, and as an AI application where you have particularly large images, I think you've had a lot of ideas and options through embedded cluster and through replicated specifically to deliver those images in a way that works, given that it can be difficult to deliver tens or even hundreds sometimes of gigabytes of images. So specifically for AI companies, I think that is a good selling point as well, a good benefit that you've received here.
Yeah, definitely. We've had many conversations about how to get our head around that problem, and I think we've got a good approach now.
Yeah, absolutely. Awesome. Well, anything else you want to add or any other comments you want to make, Tom?
I think that's good. I think we touched on most of the things that I would want to share with people. I'd like to give my thanks to both your team and to my own team. So, shout outs to Lukasz and Pavel in Krakow, and to Thomas in Atlanta and Chris in Ann Arbor for helping to put the solution together.
Awesome. That's great. Thanks.